Welcome back, Mastery Algebra 1. This is Miss Swan, and today we're going to be doing Lesson 8.3, Multiplying Polynomials. So if you think back to last semester, we learned how to multiply a polynomial by a monomial term. So say we had 3, which would be a monomial term, and we were trying to multiply it by x plus 2, which would be a binomial. What would we do? Well, we learned last semester to just distribute that 3 to both of those terms inside. So we would get 3x plus 6. So today we're going to learn how to multiply a binomial by another binomial, or even a trinomial. And to get started doing this, we're going to introduce the idea of using a box method. So if you look at example 1, if you were given the problem 3x times 2x plus 1. Well, last semester we learned we could just go ahead and distribute this 3x into both terms inside of those parentheses. But what happens if we get more complicated terms inside of there? So we're going to think of this as like it's finding the area of a rectangle with the dimensions 3x and 2x plus 1. So how do we find the area of a rectangle? Well, we multiply its length times its width. So here's what the box method is going to look like. We're going to take our binomial, so the 2x and the 1, and we're going to let that be the length of our rectangle, where each term has its own separate box. So the 2x has its own box, and the 1 also has its own box. Now we're going to take the 3x and make it equal to the width of our rectangle. So if I take a look at this first box that has the dimensions 2x and 3x, how would I find the area of that box? Well, I would just multiply its sides. So I would take 3x times 2x. Well, 3x times 2x will get me 6x squared as the area of that first box. So now if I want to look at the second box, what are the dimensions of the second box? Well, it's 1 by 3x. So 3x times 1 will just get me an area of 3x for that particular square. So now, if we were to write this out, we'd have 3x times 2x plus 1 equals the area of our first square plus the area of our second. Will get me the area of that total rectangle. So we should get 6x squared plus 3x. If we had looked at this back how we did it last semester with distribution, I would just distribute my 3x to both terms inside my parentheses. So I would have 3x times 2x plus 3x times 1. 3x times 2x will get me the 6x, and 3x times 1 gets me my 3x. So for that one, either way you look at it, you should end up with the same answer. Now if we get a little more complicated, what if we had x plus 3 times x minus 4? Now, we don't just have a monomial times a binomial. Now we have a binomial times another binomial. So this is where we're going to need to use that box method to find out what our answer would be. So we're going to think of this like we're finding the area of a patio that has the dimensions x plus 3 and x minus 4. So to find the area of a patio, we just multiply our dimensions. We're going to multiply x plus 3 times x minus 4. So each term is going to get its own side of a box. So on my top, I'm going to have an x and the minus 4 are each going to be in their own box. And on the left-hand side, my x and my plus 3 are each going to be on the side of their own box. And then we're just going to repeat the process that we did above. For this first box, I'm going to multiply my dimensions. I have x and an x. So x times x gets me x squared. For the second box, I'm going to multiply negative 4 and the x from that side. X times negative 4 gets me my negative 4x. So similarly for the last two boxes, I'm going to multiply the x and the 3 from its corresponding sides to get 3x. And for my last box, I'm going to multiply the 3 and the negative 4 to get negative 12. So now that I've found the area of each of those individual boxes, I can find the area of my total patio. So if each individual boxes I had an x squared, a negative 4x, a positive 3x, and a negative 12. So when I add all those together, I'm going to get the area for my entire patio. So if I simplified x squared minus 4x plus 3x minus 12, well, I can combine my x's to get a negative 1x. So when I multiply x plus 3 times x minus 4, you should end up with x squared plus negative 1x plus negative 12. Or another way of writing that, x squared minus x minus 12. So now we're going to try it on our own, and we're going to draw our own box for the following problem, 2x minus 3 times 3x plus 4. So I'm going to need a box that's 4 by 4. So I'm going to need a box that's 4 by 4. Because on the top of my box, I'm going to have a 2x and a negative 3. And on the side, I'm going to have a 3x and a positive 4. So now to get the area of this first box, I'm going to multiply my 3x times my 2x to get an area of 6x squared. Then I'm just going to follow the same steps for my last three boxes. So for the second one, I'm going to have 3x times negative 3, which gets me negative 6x. For the next box, I'm going to have 2x times 4, which gets me 8x. And for my last box, I'm going to take 4 times negative 3, which will get me negative 12. So now what do I do to find my solution? Well, to find 2x minus 3 times 3x plus 4, I'm just going to add up my answers from each of the boxes. So in the first box I had 6x squared, and then I got a negative 6x, a positive 8x, and a negative 12. So now I look to make sure, see if I can do any simplifying. I see that I have two terms with an x, so I'm going to combine my like terms. So I'll have 6x squared minus 6 plus 8 gets me a total of 2x, and then I still have that minus 12 on the side. So that would be my final answer. So now if we look at another example, so it wants you to, using the box method, multiply the following. So we have 3 times 2x plus 4. So last semester we learned just to distribute this 3, right? But we're going to get into some more complicated problems. So for all of these, make sure you're showing your box method. So for this problem, so I'm going to have 3 on the left-hand side and a 2x and a plus 4 along the top. So each term gets its own box. So for this first box, I'm going to take 3 times 2x. That will get me 6x. And for the second box, I'm going to have 3 times 4. Gets me a total of 12. So now if I add those two boxes up, I have a 6x and a plus 12 as my final answer. For this particular problem, I could go ahead and check my answer using the distribution method to make sure I got to the right one. So if I wanted to do that, I would take 3 times 2x, gets me 6x, and 3 times 4 gets me 12, and it checks. So I did it correct. So go ahead and hit pause and try number 2 on your own, and then check back to see if you got it right. All right, so for number 2, you should have gotten 3x squared minus 5x. Right, I'm going to walk you through a few more examples on the next page. If we look at, skip down to number 6. So once again, we have a binomial times a binomial. They each have 2 terms, which means that I'm going to have a total of 4 boxes. So on the left-hand side, I'm going to have a 3x and a positive 1. And on the top, I'm going to have an x and a negative 2. Make sure you're being extra careful of those negative signs. They should stick with the number that they are attached to. So if I repeat the steps, for this first box, I'll have a 3x times x should get me 3x squared. For the second box, 3x times negative 2 gets me negative 6x. Then I'll have a 1 times x gets me x, and 1 times negative 2 gets me negative 2. All right, so then if we write this out and add up together all of our boxes, I'll get 3x squared minus 6x plus x minus 2. And then I can go ahead and combine my like terms. So you should end up with 3x squared minus 5x minus 2. So let's go ahead and try number 8. I have another binomial times a binomial. So once again, I'm going to have 4 boxes. On the left-hand side, I'm going to have a 2x and a plus 1. And on the top, I'm going to have a 2x and a minus 1. So now when I go ahead and multiply, 2x times 2x gets me 4x squared. 2x times negative 1 should get me negative 2x. On the bottom, I should get 2x times positive 1 gets me positive 2x, and 1 times negative 1 gets me negative 1. Now, if I look at these two diagonal boxes, I notice that they're both like terms. They both have just an x. So I can go ahead and combine those. So I have a 4x squared from my top box, and now I can combine my like terms. So I have a positive 2x and a negative 2x that will actually cancel each other out. So now I'm just left with my 4x squared and my minus 1. All right, skip down to number 10. I have x plus 1 squared. So if you think back to exponents last chapter, x plus 1 squared is really x plus 1 times itself, right? So another way we can rewrite this is x plus 1 times x plus 1. Then it becomes a problem just like we did above. I have a binomial times a binomial. So I'm going to have 4 squares in my box. I'm going to have an x and a plus 1 on the left, and then another x and a plus 1 on the top. Now I just go ahead and repeat those same steps. So x times x gets me x squared. X times 1 gets me x. 1 times x gets me another x. And 1 times 1 gets me positive 1. So now if we add up all of those squares, I get x squared plus x plus another x and plus 1. Always make sure your final step is combine those terms. So I have x squared plus 2x plus 1. All right, go ahead and flip to the last page. We're going to do a couple more together. So number 13. So if we look about what's different on this one, now I have x minus 1 times x squared minus 4x plus 2. So instead of having a binomial times a binomial, now I have a binomial times a trinomial. So I'm going to still solve it using my box method, except now along the top of my box I'm going to have 3 spots since that has 3 terms. So on the left hand side I'm going to have my x and my negative 1, and now along the top I'm going to have an x squared, a minus 4x, and a positive 2. So I just added another column to my box. So we're going to still use the same method. So x times x squared will get me an x cubed. X times negative 4x gets me negative 4x squared. X times 2 gets me 2x. Then I go to the next row. Negative 1 times x squared gets me negative x squared. Negative 1 times negative 4x gets me 4x. And negative 1 times 2 gets me negative 2. So now, like the other ones, I can look and find my like terms. I have 2 terms that have x squareds, and I have 2 terms that have x's. So when I write my final answer out, I had 1x cubed. Now I want to look at my x squareds. I had negative x squared minus 4x squared for a total of minus 5x squared. And then looking at my x's, I have a 4x and a 2x, which gets me plus 6x. And finally, that minus 2 on the end. So you should end up with x squared minus 5x squared plus 6x minus 2. All right, let's check out one of those word problems all the way at the bottom. So if I was given the length of a rectangle is 3x plus 2 and the width is 2x minus 7, what is the area of the rectangle? If you think back on how we find area of a rectangle, well, the area is just going to be the length times the width. And it gives us the length is 3x plus 2 and the width is 2x minus 7. So if we plug those values in for that length and width, now it just becomes a problem we can use the box method for. So I have a binomial times a binomial, which means I'm going to have 4 boxes. On the left-hand side, I'll have 3x and a plus 2. And on the top, I'll have a 2x and a minus 7. So if I multiply inside my boxes, 3x times 2x gets me 6x squared. 3x times negative 7 gets me negative 21x. 2 times 2x gives me a 4x. And 2 times negative 7 gets me negative 14. So now I've got the area of each of those individual little boxes, and to find the whole thing, I just add them all together. So 6x squared, I have a 4x and a negative 21x. If I add those together, I should get negative 17x, and I still have that minus 14 in the last box. So don't forget, word problem, what should we always write? A sentence. So if I wanted to answer the question, what is the area of a rectangle? I would say the area of the rectangle is 6x squared minus 17x minus 14 units squared. All right, go ahead and hit pause and try all the other problems on your own. Make sure you're showing all your work and using that box method to multiply out your polynomials, and check back once you're all done for the answers. Welcome back. Here's your answers for you. Remember, make sure you showed all of your work and used the box method for all of these problems. If you have any questions on any of these, please make sure you come and see us for help. And for that last one, please make sure you wrote your sentence. All right, that's all for today. Don't forget, do your best, forget the rest. Bye for now.